Hello students, welcome to IMS Academy. Excellent. Here I am welcoming all of you for the previous year questions of communication system subject series. So earlier we have discussed 3 sessions regarding the communications previous year questions. We started from 2023 and then 2022 and then 2021, right? So in this particular session we are going to discuss the gate questions related to 2020. Okay, so in this particular session, I have selected the important questions which are asked in the GATE 2020 year, okay, which are from EC branch, and whatever the questions I am going to discuss now, these questions will be helpful for both the branches, EC and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session, right? So all of you quickly share this video link with all of your friends. And whoever couldn't attended earlier sessions, so kindly watch those sessions in your free time. Those lectures are available in our playlist, right? So in the YouTube, just type IMS Gate Academy. In our YouTube channel, you just go to the playlist and just check regarding the previous year questions of communication system subject. So you can see the previous sessions, okay? And in this particular session, we are going to discuss regarding the 2020 questions, okay? So this is the first question. This question weightage is 2 marks and this question is of MCQ. That means among the 4 choices only one option will be correct. This question related to the first chapter. So all of you give it a try. Yeah, first let us read the question. for the modulated signal x of t. X of t already it is the modulated signal. Okay, they have given m of t into cos 2 pi of ct. So this is nothing but DSBS signal. You are having the message signal and you are having the carrier signal. Just product of those two signals is nothing but DSBS signal. Okay, so that signal they have given as one of the input for the multiplier. The message signal, here they have mentioned regarding the message signal m of t as 4 cos 1000 pi t, 4 cos 1000 pi t, and the carrier frequency is 1 megahertz. The signal x of t, the signal x of t is passed through a demodulator. This is the demodulator circuit diagram they have given. So in this particular demodulator circuit diagram, the final output you are having y of t. So regarding the output expression they are asking. So in this particular demodulator, if you observe, you are having the multiplier. For the multiplier, one of the input is the modulated signal x of t, and the other one is the carrier signal cos 2 pi into fc plus 40 into t. And the output of multiplier they have passed through the low pass filter, which is having the cutoff frequency 510 Hz. Now they are asking the final output expression. Here you are having 4 choices. Whichever is the correct one, you can choose. Okay, right. So first of all, let us write x of t expression. X of t equal to m of t into cos 2 pi of ct. X of t equal to m of t into cos 2 pi of ct. Where fc equal to 1 megahertz. Where fc equal to 1 megahertz. For the time being, I am not substituting that value. I will keep fc as it is. Okay. And regarding m of t, they have mentioned as 4 cos 1000 pi t. M of t as 4 cos 1000 pi t. M of t as 4 cos 1000 pi t. 4 cos 1000 pi t. And then write this carrier signal as it is. Cos 2 pi f ct. Cos 2 pi f ct. Right. This is your x of t signal, that is nothing but modulated signal. Now here you are having, for the multiplier, one of the input is x of t, whereas the other input is cos 2 pi into fc plus 40 into t. So for the time being, let us write the output of the multiplier. Output of multiplier. Output of multiplier is equal to whatever x of t expression we are having, I am writing as it is 4 cos 1000 pi t, 4 cos 1000 pi t into cos 2 pi f ct, into cos 2 pi f ct. And then here you are having one more signal, that is nothing but cos 2 pi into fc plus 40 into t. Cos 2 pi into fc plus 40 into t. Right. So this is the x of t signal and this is the carrier signal, cos 2 pi into fc plus 40 into t. Right. Now if you observe carefully, here you are getting like cos A cos B. Regarding this term, we will see later, but for the time being, just observe here, you are having like cos A cos B format. Okay. So multiply and divide with 2. Multiply and divide with 2. So here I divide with 2 and here I am multiplying with 2. So here I am just multiplying 2 pi with both the terms. So that means you will get 2 pi fc, 2 pi fct plus 2 pi into 40t. That is nothing but 40 into 2, 80 pi t. Okay. 2 cos A cos B. I hope all of you know the standard trigonometric equation regarding 2 cos A cos B is nothing but cos sum plus cos difference. So for the timing I'm writing here 2 cos A cos B, 2 cos A cos B is equal to cos sum plus cos difference. Two cos A cos B is equal to cos sum plus cos difference. Cos sum plus cos difference, right? So here 2 times, that means you are having 2 cos 1000 pi t, 2 cos 1000 pi t, then 2 cos A cos B is nothing but cos sum, So here whatever the terms here you are having, just add both the terms, right? Here 2 pi f ct plus 2 pi f ct, that means you are going to get 4 pi f ct plus 80 pi t, 80 pi t. 2 cos A cos B is nothing but cos sum plus cos difference. Cos difference. You can subtract, okay. Say for example, here I am considering this is the A term. When you observe these two, just by observing these two, this term is greater when compared to this one, right? So for the timing you can consider this is A and this is B. 2 cos A cos B is nothing but cos sum plus cos difference. So you can separate this one from here. So 2 pi f ct, 2 pi f ct will get cancelled. You are going to get 80 pi t. You are going to get 80 pi t. 80 pi t. Right. Now here you are having cos term, here also you are having individually cos terms. Multiply this term with both. Two cos 1000 pi t, 2 cos 1000 pi t into cos of this entire term, cos 4 pi f ct plus 80 pi t, 4 pi f ct plus 80 pi t, plus multiply this term with that last term, 2 cos 1000 pi t, 2 cos 1000 pi t into cos 80 pi t, cos 80 pi t. Cos 80 pi t. Now you are getting the form like 2 cos A cos B. Once again, 2 cos A cos B is nothing but cos sum plus cos difference. Once again we are using the same trigonometric equation, right? Cos sum plus cos difference. So here cos sum, you can add both the terms here, both the terms. So 4 pi f ct plus 80 plus 1000, that is nothing but 1080 pi t. 2 cos A cos B. For the timing consider this term as A and this term as B, because when you observe these two, so this is greater, right, when compared to this term. So you can consider this A, this B. 2 cos A cos B is nothing but cos sum plus cos difference. Cos difference. So you can separate this term from here. So 4 pi f ct, 80 minus 1000. 80 minus 1000 is nothing but minus 920. 80 minus 1000 is nothing but minus 920 pi t. Minus 920 pi t. Okay. Similarly, here also you can apply same formula. 2 cos A cos B. 2 cos A cos B is nothing but cos sum plus cos difference. Cos sum plus cos difference. So 1000 pi t plus 80 pi t. So that means you are going to get 1080 pi t. 1080 pi t plus cos difference. Cos difference 1000 minus 80 is nothing but 920 pi t. 920 pi t. Right. So this expression you got at the output of multiplier. At the output of multiplier. Now whatever the output expression you got at the output of multiplier, that one we are passing through low pass filter. We are passing through low pass filter which is having the cutoff frequency 510 Hz, right? Which is having the cutoff frequency 510 Hz. So that means, so generally we will consider the frequency starting from 0 and up to 510, but here for symmetrical purpose they have considered negative frequency also. That is the reason they have mentioned from minus 510 to 510, but otherwise you can consider from 0 to 510. 0 to 510 Hz, it is passing. Other than that band, it is not passing, right? Otherwise, if you want to consider negative frequency zone and positive, so from minus 510 to 510 you can consider. Other than that, it is not allowing. During this range, it is having the pass band gain as 1. So with this understanding, if you observe, here already they have given FC is 1 megahertz, FC is 1 megahertz, right? So here you are getting FC term, right, 4 pi FCT. So obviously this overall term is having very high frequency. Right. Similarly, this particular frequency also 4 pi FCT, from there you are subtracting this much. Okay. So this is also very high frequency. So these two are high frequencies. It won't pass. Okay. So at the output of multiplier, whatever you are getting 4 terms. Out of 4 terms, now we are analyzing at the output of low pass filter which terms you are going to get. Okay. So first term, second term, it is not passing. What about this term? So here whatever you are having, I am writing in the format as 2 pi f. 2 pi f format, 2 pi into, okay, here we can write 540. 2 into 540 is nothing but 1080, right? Similarly, here also I am writing in the 2 pi f format, 2 pi into 460, 460t. Now you can observe, you are getting like cos 2 pi ft format. So that means here this is the frequency, 540 Hz is the frequency, here 460 is the frequency. So now tell me, among these two frequencies, the low pass filter is going to allow which term? Whether both or only one? If only one, which term that low pass filter is going to pass? Any guess? At the output of low pass filter. At the output of low pass filter. Output of low pass filter is y of t, which is having the cutoff frequency 510 Hz. Output of low pass filter equal to y of t. So cutoff frequency is 510 Hz. So that means it is passing up to 510 Hz frequency. But this frequency is what? Beyond. So that means this term also not allowing. Only this last term is allowing. Right? Only this last term is allowing. So that means you can write this direct expression, cos 920 pi t. 920 pi t. I hope it is clear for everyone, right? So in this way, you have to analyze stage by stage. In this particular circuit diagram, you are having the modulated signal and then local oscillator carrier frequency you are having. These two they have given as inputs for multiplier. Output of multiplier we calculated. After that, we are passing that expression through the low pass filter. So according to the cutoff frequency, we will identify among those terms which term is going to produce. So here finally you are getting cos 920 pi t. Cos 920 pi t. So that means option B is the correct answer. Option B is the correct answer. Okay, right. Here for understanding purpose, I have solved this question completely, but once if you are able to understand the mechanism here, whatever operation with the help of this coded, with the help of this trigonometric equation, whatever we are doing, like 2 cos A cos B means cos sum plus cos difference, right? So instead of writing all the steps, you can directly write the addition of frequency and difference of frequency like that, okay? 2 cos A cos B is nothing but cos sum plus cos difference. Like that, you can analyze. After that, finally, you are going to get, okay, whichever terms you don't have high frequency. Say, for example, in these two, obviously, you are having high frequency, so those terms won't come. So in these two, you are having low frequency terms, but since the low pass filter cutoff frequency is 510 Hz, because of that reason, this particular low pass filter is allowing only this one. Say for example, if the low pass filter cutoff frequency in the question, if it is designed like say for example 600 Hz, in that case these two terms will be allowed like that, right? So according to the cutoff frequency, it will vary. So for this question, option B is the correct answer, right? Now let us move on to the next question. This question is also having 2 marks weightage. This question is of NET type. Answer will be a number. Yeah, time up. So whatever the answer you might have got, all of you please share in the chat. Yeah, those who are still trying, you can try. Okay, whatever the answer you are getting, meanwhile you can reply in the chat. Right. So in this particular question, they have mentioned they have given two signals. One is phase modulated signal, another one is frequency modulated signal. So here they have mentioned, here PM stands for phase modulated signal, whereas FM stands for frequency modulated signal, right? And here message signal is M of t. Regarding message signal M of t, they have shown in the figure. So that figure is here. Regarding the message signal M of t, you are having the waveform like this. So here x-axis is the time, which is in the order of seconds, whereas y-axis is nothing but amplitude. It is in the order of volts, right? So this particular signal exists from 1 second to 7 seconds. From 1 to 3, it is a linear function. From 3 to 6, it is a constant function. And from 6 to 7, it is linearly decreasing, right? And regarding the phase modulated signal and the frequency modulated signal, the equations they have given, here cos 1000 pi t plus kp into m of t, whereas here cos 1000 pi t plus kf into integral minus infinity to t m of tau d tau, right? Yes, very good, Manoj. Excellent, excellent. Here kp is nothing but phase deviation constant, units are radians per volt, and kf is the frequency sensitivity or frequency deviation constant. It is in the order of radians per second per volt, right? So here they are asking that if the highest instantaneous frequency of both phase modulated and frequency modulated signals are same, then they are asking the ratio of kp and kf. So you will get in the order of seconds. When you do the ratio of kp and kf, here you can observe radians per volt, here you are having radians per second per volt. So radians per volt will get cancelled. Here in the denominator you are getting per second. When you go into the numerator, you will get in the order of seconds, right? In the order of seconds. So first of all, let us write the instantaneous frequency. Instantaneous frequency. I hope all of you know the formula. Whenever you are having cos signal or sine signal, so whatever this entire term, you can consider like theta of t. Theta of t. It is the angle term, right? So from there you can write the instantaneous frequency. Fi equal to 1 by 2 pi into d theta of t divided by dt. D theta of t divided by dt, right? So here first let us consider regarding the phase modulated signal. Instantaneous frequency 1 by 2 pi you can keep as it is. Here we are performing the differentiation with respect to t. And regarding theta of t, here in this entire expression, this is the theta of t. 1000 pi t plus kp into m of t. 1000 pi t plus kp into m of t. Kp into m of t. Right. So here perform the differentiation. 1 by 2 pi I am keeping as it is. You can perform differentiation for both the terms individually. Here 1000 pi is the constant. 1000 pi is the constant. Differentiation of t with respect to t you will get 1, right? Plus kp is the constant, we can keep as it is. Then differentiation of m of t with respect to t. dm of t divided by dt. Right. So here 1000 pi divided by 2 pi plus kp divided by 2 pi into dm of t by dt. dm of t by dt. Here pi will get cancelled to 500 times. So that means you are going to get 500 plus kp by 2 pi into dm of t by dt. So this is the instantaneous frequency in the phase modulated signal. But in the question they are asking that the highest instantaneous frequency. Highest instantaneous frequency in order to get what will be the dm of t by dt term, whether it should be maximum or it should be minimum, so that you will get maximum instantaneous frequency in the phase modulated. What is the answer, Manoj? Even other students also can answer in the chart. In which condition you are going to get the maximum instantaneous frequency in phase modulated signal? Because here 500 is a constant, okay, it is not varying, right? So we can keep as it is. Here Kp anyway constant, 2 pi is a constant. Now tell me dm of t by dt, whether it should be maximum or it should be minimum, so that you will get maximum instantaneous frequency. I hope all of you can answer, right? All of you can answer. See, just observe these two terms, what you are performing. You are performing the addition operation, right? So here I want to get maximum value. So that means when you are considering this is the maximum. Yes, very good, Manoj, very good. When you are considering this is the maximum, so obviously this overall term you will get maximum. You are adding that term with 500. So that means resultant term you are going to get maximum. Suppose if you have considered minimum, obviously here you are getting, obviously overall value will be less when compared to the earlier case, right? So dm of t by dt max we have to consider, right? Now whatever the message signal waveform they have given in the question, I have considered here, right? So here if you observe from 1 to 3 interval, in the 1 to 3 interval you are having a straight line, you are having a straight line, right? So can you tell the slope of this particular line? During, for the interval t lies between 1 and 3, can you tell the slope of the line? Slope of m of t, dm of t by dt. For the interval 3 to 6, for the interval 3 to 6, what is dm of t by dt? Similarly, for the interval 6 to 7, for the interval 6 to 7, what is dm of t by dt? Yes, very good, Manoj, very good. Even other students also can answer. So here slope of the line is nothing but y2 minus y1 by x2 minus x1. Here y2 is 10 minus y1 is 0. Here y2, see you can observe this line, you are having, this is the starting point, this is the ending point, right? So 10 y2 minus y1, y2 minus y1 divided by x2 minus x1, 3 minus 1. Okay, so that means here you will get 10 divided by 2, that is nothing but 5. Units you will get in the order of volt per second, volt per second. Between 3 to 6, you are having the constant, derivative of constant is 0. Derivative of constant is 0. Here units are volt per second. Yes, very good, Manoj, very good. So here between 6 to 7, here y1 value is 10, whereas y2 value is 0. So that means 0 minus 10 divided by. Here x2 is 7, x1 is 6. So 7 minus 6, so minus 10 divided by 1. That is nothing but minus 10, units are volt per second. Or you can easily observe, whenever the function is linearly increasing, you will get positive slope. Whenever the function is linearly decreasing, you will get negative slope. And whenever the function is constant, so slope of that particular line is 0. So here for understanding purpose, I have written the slope in each region. In the interval 1 to 7, I have made into 3 intervals, and for each interval I have calculated the slope. Okay, but just by observing this waveform only, since our requirement is dm of t by dt should be maximum, right? So just by observing this waveform, you can easily understand whenever the function is linearly increasing, obviously there you will get maximum slope. So you don't need to calculate these two. But for understanding purpose, I have solved in each and every interval, right? So finally, among all of these, dm of t by dt max, dm of t by dt max is nothing but you are having one positive value, one negative value, and other value is 0, right? So among all, obviously this is the maximum, right? So 5 volt per second. 5 volt per second. Now you can substitute this value in this particular equation, right? So I am writing here instantaneous frequency in phase modulated signal for the maximum instantaneous frequency value. Here we got 500 plus kp by 2 pi into dm of t by dt max. Regarding that, just now we got 5. dm of t by dt max, that is nothing but 5. So as of now, whatever the expression you got, you can label this one as equation 1. Yes, very good, Manoj, very good. Now let us consider with respect to FM signal. Let us calculate instantaneous frequency. In FM signal, instantaneous frequency, formula will remain same, 1 by 2 pi into d theta of t by dt, where theta of t is nothing but this entire expression, 1000 pi t plus kf into integral m of tau d tau, kf into integral minus infinity to t m of tau d tau. Right. So here 1 by 2 pi you can keep as it is. Now differentiation of this term, 1000 pi is the constant, we can keep as it is. Derivative of t, you will get 1 with respect to t. Here kf you can keep as it is. Now what is the term you are going to get here? Any guess, Manoj? Here kf is the constant, we can keep as it is. We are performing differentiation and then integration. So differentiation, integration will cancel. So finally you are going to get m of t, right? Kf into m of t. So 1 by 2 pi you can multiply with both the terms. So here pi will get cancelled, otherwise you can write one more step, no problem. 1000 pi divided by 2 pi plus kf divided by 2 pi into m of t, Here pi will get cancelled to 500 times. So you are getting the expression 500 plus kf divided by 2 pi into m of t. So just like earlier, yes, very good, Manoj, very good. So just like earlier, here in FM also we want to get instantaneous frequency maximum, right? So here 500 is the constant, kf and 2 pi are the constant, so obviously m of t should be maximum. Then only you will get instantaneous frequency maximum in FM also. Instantaneous frequency maximum in FM is nothing but 500 plus kf divided by 2 pi into m of t max. Now just observe the waveform regarding m of t. What is the maximum value of m of t? All of you please respond. All of you share your answer in the chat. What is the maximum m of t value from this waveform? Yes, very good. Just observe here, you are having 0 volt and then 10 volt, right? In between, it is varying here and similarly here varying. So that means among among all the voltage levels, here in this particular waveform if you observe, among all the voltage levels, this voltage level is the maximum, right? So M of t maximum is nothing but 10 volts, 10 volts. So from here you will get, regarding Fi in Fm, maximum value is nothing but 500, you can keep as it is, plus Kf divided by 2 pi, into 10, So this is equation number 2. So with respect to Pm, we got the maximum instance frequency like this. With respect to Fm, we got the maximum instance frequency like this. Now in the question they have mentioned that both are same. If the highest instance frequencies of PM signal and FM signal both are same, then they are asking the ratio. So that means then the ratio of Kp and Kf they are asking, right? So whatever 1 and 2 we got with respect to instantaneous frequency, since they have mentioned both are equal, now you can equate whatever you are having right hand side in both the equations, you can equate, right? 1 and 2 are same according to the given question. So that means here 500 plus 500 Kp into 5 divided by 2 pi is equal to, here you are getting 500 plus Kf into 10 by 2 pi. Kf into 10 by 2 pi. So here 500 will get cancelled, right? So after that you are getting Kp into 5 divided by 2 pi is equal to Kf into 10 divided by 2 pi. So here 2 pi will get cancelled, 5 two times. So here in this question they asked that ratio of Kp and Kf. So that means Kf you can bring left hand side, it will come into the denominator. So you are having 2. Here units are seconds, right? So in this question they asked Kp by Kf, so that's the reason the final answer for this question is 2. Say for example if they asked the ratio of Kf and Kp, then you have to make the reciprocal, 1 by 2 is nothing but 0.5. So in this way, whenever you are getting any question, after you are solving, especially for NIT type of questions, you have to enter the answer, right, from your keyboard. Okay. So before you are entering your answer, just look at the question. Okay. So in which order they are asking. So according to the convention, according to the question point of view, the answer will vary. Say for example, up to here you might have done correctly. Say for example in this question, since they asked Kp by Kf, obviously 2 is the correct answer. But suppose if they asked Kf by Kp, then you have to mention 0.5 like that. Okay, I hope it is clear regarding this question. So now let us move on to the next question. All of you give it a try. So during the exam, there will be negative marking, but here when you are attending the classes in the online, in the YouTube, okay, so you don't have any negative marking, right? So all of you feel free to mention your answer in the chart, okay, right? So there is no negative marking at all, right, here. So even suppose due to any reason if you got wrong answer, no problem at all. I am giving the explanation, right? So later you can do the correction where you done the mistake, right? Yes, very good, Manoj, very good. Yes, option D is the correct answer. Option D is the correct one, right? So in this particular question, they have mentioned that you are having a digital communication system which transmits a block of n bits. You are having a block, in that block, so that means n bits, group of n bits, they are considering as a single block, okay, right? The probability of error in decoding a bit is alpha. In any particular bit, you are having total n bits are there. So in any bit, if you are getting the error, so for that the probability of getting error in any bit, it is alpha. Now the question is, they have mentioned here, the error event of bit is independent of the error events of other bits. This is a very interesting point in this particular question. The error event of the bit is independent of the error events of other bits, right? The received block is declared erroneous if at least one of its bits is decoded wrongly. Among these n bits, even if 1 bit or 2 bits or 3 bits, even if at least 1 bit is error, so that they have declared as the entire block is having error, or whatever the block they have received, that is the error block, right? Now the question is the probability that the received block is erroneous, right? So in this particular question, they have mentioned that probability of getting error in a bit, that is alpha, right? So probability of getting correct bit, so that is nothing but 1 minus alpha in any particular bit, right? So here they are asking regarding the probability that the received block is erroneous. Okay, for the time being, let us consider the case where you have received all the bits correctly, right? So you are having total n number of bits. If all the bits you have received, correctly, right? So that means each one is having the probability. In order to get correctly, you are having 1 minus alpha. Each bit, in order to get correctly, you are having 1 minus alpha. Like that, total you are having n bits. Right? So that means you can multiply, because they have mentioned here whatever the probability of error or correctness, that is independent, right? So whatever the probabilities here you got, you can multiply. So that is nothing but 1 minus alpha, 1 minus alpha, 1 minus alpha. Like that you are considering n times. So that means here you will get power n. So this is the probability. That the received block is correct. Probability of received block is correct. Now they haven't asked regarding this probability. What they have asked? They asked the probability of the received block is erroneous. Probability of received block is erroneous. So just like here, probability of error, if you know, total probability is nothing but 1. From there I have separated this one. That is nothing but correct probability. In a similar way, here the received block, in order to get correct, all the bits you should receive correctly, right? So for that the probability we have calculated. Now from the total probability is nothing but 1. So from there we can subtract this probability. So this is nothing but the probability of the received block is erroneous, right? 1 minus alpha whole power n. So that means option D is the correct answer. Option D is the correct answer, right? I hope it is clear for everyone. So now let us move on to the next question. This is the last question for today's session. This question is of NIT. So obviously answer will be a number and this question weightage is of 1 mark. All of you give it a try. This is the question based on entropy. All of you give it a try. Whatever the answer you are getting, you can mention in the chart. Manoj, have you attended any of the earlier sessions in our YouTube channel, or are you attending very first time in our IMS Gate Academy YouTube channel live session? Yeah, attended. Very good, very good. So, based on the possibility, try to attend whatever the sessions that are coming in our YouTube channel according to your branch. You can attend all the sessions in live, but due to any reason, if you miss any classes, no issue at all. You can watch the recorded lectures will be there in the playlist. Okay, so you can watch those lectures in your free time. Right. So all of you please share the answer in the chart. Yeah, in this question they have mentioned that binary random variable. As the name implies, binary means you will get two possible values. In general, we will consider like 0 and 1. Or if you want, you can consider any other values also, no problem. Okay, so in this particular question, they have considered the random variable is x. Regarding that, they have considered the possible values either +2 or -2. Okay, so regarding the probability, in order to get +2, they have mentioned it is alpha, right? So probability of x equal to +2, they have mentioned alpha. Then what will be the probability for getting x equal to -2? All of you please respond. Probability for getting x equal to +2 is alpha. What will be the probability for getting x equal to -2? They haven't mentioned in the question, but you can guess based on the previous question. In the previous question, I have given the hint. Even this question, you can take the help from your tossing a coin. You will get either head or tail, or tossing a dice. Okay, from there also you will get the clue. See, here you are getting only two possible outcomes, either plus 2 or minus 2, right? Plus 2 or minus 2. So for one case they have given probability as alpha, so that means for other case you will get only two possible outcomes, right? Yes, very good Manoj, very good. So sum of all the probabilities equal to 1, equal to 1. From there, if you are subtracting this probability, that is nothing but the probability of getting this value, like that. Okay, suppose if you are considering head or tail, so regarding head if the probability is 0.5, regarding tail 1 minus 0.5 is nothing but 0.5, like that. Okay, 1 minus alpha. Right. Here you are having two possible outcomes, right? Regarding the first one, the probability is alpha. So total probability equal to 1. So from 1, if you are subtracting this probability, so 1 minus alpha. Or when you are adding both, the resultant total probability you are going to get 1, like that. 1 minus alpha. Right. So in this question, they are asking the value of alpha. You can round off to the 1 decimal place. For which the entropy of X is maximum. Entropy of X is maximum. Right. So I hope all of you know the formula regarding entropy. Entropy is nothing but, here you are having discrete random variable. Discrete random variable. So I am considering here summation I equal to, generalized case you will get 1 to 2, because you are having only two possible values. I am considering like 1 and 2. I equal to 1 and 2. Probability into log 1 by probability. Probability into log 1 by probability. Log 1 by probability is nothing but information, right? So probability into information, that is nothing but, like that you have to do for all the possible outcomes. From there you are going to get entropy. So now substitute here. First case, probability is alpha, log 1 by alpha. Can you guess what is the base value for this log? Manoj, what is the base value for this log? Even other students also can mention in the chart. What is the base value for this logarithm? In another symbol, you are having 1 minus alpha is the probability, log 1 by 1 minus alpha. All of you please respond. This is a very interesting. What is the base value for the logarithm? Yes, very good Manoj, very good. Here, this is a concept we are studying in the information theory. So in the information theory, logarithm base value is 2. Okay, for generalized case, it can be B, but since we are dealing about binary values, here base value is 10. Sorry, base value is 2. Whenever you are doing the calculations regarding signal to noise ratio, right, or voltage gain, current gain or power gain, that time logarithm is there. So their logarithm based on you are considering, right? So you have to be very careful when you are considering the logarithm notation. So whenever base value 10, you no need to represent, but whenever base value is 2 or base value is E, you can represent, right? So this is the entropy. This is the entropy, H equal to alpha into log 1 by alpha. Probability is alpha, log 1 by probability. And another case, probability is 1 minus alpha, log 1 by probability 1 minus alpha. So this is the entropy you got. This is the entropy you got. Now the question is, they are asking the alpha value. Alpha value in such a way that the overall entropy you should get maximum. You should get maximum. So for easy understanding, here I will consider one tabular form. So here I am considering alpha value, and then accordingly I am calculating the corresponding entropy. So first of all, let us consider alpha value 0. What is the entropy? Similarly, alpha value 1. What is the entropy? Similarly, alpha value 1 by 2 or 0.5. What is the entropy? All of you give a try. All of you try for one case. Just in this entire equation, substitute alpha equal 0, what will be the entropy? Alpha equal to 1, what will be the entropy? Alpha equal to 0.5 or 1 by 2, what will be the entropy? See, it is very simple. Alpha value when you substitute 0, here overall term you are going to get 0. What about this term? What about this term? Alpha value 0, 1 minus 0 is 1, but here 1 minus 0 is 1, log 1 is nothing but 0, log 1 is nothing but 0. So overall you are getting 0. When you have considered alpha value 0, overall term you are going to get 0. With this understanding, give a try for alpha equal to 1 and similarly alpha equal to 0.5. Manoj, what is the answer? Yes, you can substitute here alpha value 1. Alpha value 1, log 1 by 1. Log 1 is nothing but 0. Here 1 minus 1 is 0. Overall term you are going to get 0. So when you have considered alpha value 0, that time output or entropy value is 0. When you have considered alpha value 1, that time also entropy you got 0. Entropy you got 0. Yes, very good Manoj, very good. Right. So when you have considered alpha value 0, that time you are getting 0. Alpha value 1, that time also 0. Okay, in between 0 and 1, I have considered 0.5. Right. So here you can substitute. 1 by 2 log 1 by 1 by 2. That one directly I am writing it as log 2 base 2. Log 2 base 2 plus. Here 1 minus 1 by 2. 1 minus 1 by 2, that is nothing but, okay, I will write one step here. 1 minus 1 by 2, then log of 1 by 1 minus alpha value I have chosen 1 by 2 base 2. So from here log 2 base 2 is nothing but 1. So 1 by 2 I am keeping. Here 1 minus half is nothing but half. Here 1 minus half is nothing but half. 1 by 1 by 2 is nothing but 2. So log 2 base 2 you are getting. So that is nothing but 1. Okay. If you want, I will write one step here. So from here you are getting 1 by 2 plus 1 by 2. So which is nothing but 1. So when you are varying alpha value from 0 to 1, in between you will get 0.5. Initially at 0 you are getting entropy 0. When you have considered alpha value 1, that time also 0. Okay. And here alpha value 0.5 when you have considered, that time you are going to get the maximum value of entropy, that is 1. Right. See here alpha is nothing but probability. Alpha is nothing but probability at x equal to plus 2, right? So that means probability value always less than or equal to 1, right? So the probability minimum value could be 0 and maximum value could be 1, right? Within 0 to 1, any value we can consider. Okay. So in your free time, just verify with the other alpha values, okay, and you can verify. Okay. So here you will get only at 0.5. For alpha equal to 0.5, at only that particular value, you will get the maximum entropy. For other values, when compared to at 0.5, okay, you are getting maximum value as 1. When compared to that 1, in other values of alpha, you will get less only, right? So the question is, here they are asking, for what value of alpha, you are going to get maximum entropy. So that means, when whatever the binary random variable you are having, if both the possible values are having the equal probability, in that case only you are going to get maximum entropy, right? So here the question is regarding the alpha value. So that means here the final answer for this question is 0.5. 0.5 is the correct answer. I hope it is clear for everyone. So in this particular session, we have discussed the selected questions which are asked in the 2020 year, right? So these questions, whatever the concepts we have discussed, these concepts will be helpful for your coming GATE exam also. So in this particular session, Manoj has answered most of the questions correctly. So please continue, right? So please continue the same spirit and try to attend like this in the upcoming live sessions also. Right. So tomorrow we are having one more session. So in this particular session, we will discuss regarding the communication system subject only. We'll discuss the selected questions which are asked in the 2019 year, right? So we'll discuss those questions. So all of you kindly join tomorrow's session sharply at 3 p.m. right? So we'll discuss variety of questions in the tomorrow sessions, right? Tomorrow session, okay. So similarly, whatever the other sessions which are coming in our YouTube channel, so kindly try to attend all the sessions in live and try to share this information with all of your friends, right? So that they also will attend this session in live and they also will get benefited, right? So all of you kindly subscribe our YouTube channel and click on the bell icon so that you will get instant notification. You won't miss even single video, right? So we'll meet you all in next session, right? That is on tomorrow. Thank you everyone. Thank you Manoj.